Hello and welcome to Maths with Jacob. This lesson will focus on reflection. Most of us look in the mirror each day. We see a reflection of ourselves. The reflection is exactly the same size as the original image, but it is reversed. So you can see this little person is looking at himself in the mirror. Exactly the same size, but the person in the mirror is looking the other way, so it's reversed. When an image is reflected in a mirror, the surface of the mirror performs the same function as an axis of symmetry. So what we mean is this. There's the letter C. It's looking at itself in this mirror here. Let's pretend that's a mirror, and that's what it sees on the other side. This can also be seen as an axis of symmetry, where this is a reflection of that, and vice versa. So it's exactly the same object, except it's turned the other way. It's reversed. It's reflected. Exactly the same with the N. It's looking at itself in the mirror, or if you look at that as an axis of symmetry, where you have a reflection, a mirror image, that's exactly what you see on each side. And it's the same with the letter R. Exactly the same size, only there's a reversal. Congruence. When an object is reflected in a mirror, the image inside the mirror is exactly the same shape and size as the original object. We say that the object and the image are congruent. That's what the word congruent means. It means it's exactly the same shape and size as it is for this young individual and for each of those letters. So let's have a look at some examples of reflection. Here we have this blue arrow which is pointing to the left. If we think of that as a mirror, that is the reflected image. That is the reflection of this one. There's the mirror line. Both shapes are the same distance from the mirror line. So the blue to the mirror line is the same distance as the orange to the mirror line. They're exactly the same shape and size, but they're reflected, which means they're pointing the other way. Let's look at some examples. Draw a reflection for each of the following objects using the given mirror line. If that's the object, that's the triangle. It's looking at itself, if we pretend that's a mirror, or an axis of symmetry which does the same job, that's what we see on the other side. The distances are exactly the same, the object is the same shape and size. And in a similar manner, this four-sided figure or quadrilateral is reflected in that dotted line. There's the object, there's the reflection, exactly the same shape and size, but it's just a reversal. And it's very easy to see for this simple triangle, exactly the same thing is happening. There's your mirror, object, image, reversal, same shape and size. Exactly the same here. There's your mirror. You can see exactly what's happening. Just pretend that's a mirror and that object is looking at itself there, or that plane shape is looking at itself there. Even on a number plane, exactly the same thing happens. If you look at the y-axis as a mirror or an axis of symmetry, there's your original, for example, and that could be your image or vice versa. And it doesn't matter where the mirror line is, it could even be on a slope, it doesn't matter. When you have your original and then you have your image, and that's exactly what we see there. Okay, so it's quite straightforward. That line goes to there, that line goes to there, and we have the reflection happening in that mirror. So this video has introduced us to the idea of reflection, where an original image is reflected in a mirror. It sees itself on the other side of the mirror. The original and the image are the same distance from the mirror, and they are the same shape and the same size.